Hi everybody, thanks for joining me for another video. We are moving on in our Algebra Part 2 series, and up to this point in the algebra we have worked on coordinate grid, how to plot points on a grid, and we worked on drawing lines through those. And then most recently the video was on slope, and so how we can actually describe what a line is doing using numbers. And so right now we're just focusing on straight lines, and we're going to continue building on those two ideas we've already learned about. So slope shows where a line is going. It's either positive or negative. It's either increasing or decreasing. And the rate at which it's moving is called rise over run. And so we talked in the last video about how we can find that. So we can give a number to express what a line is doing and where it's going, okay? And that's all we've worked on up to this point. But really that's leading us to something called linear equations, all right? That's what we're gonna work on today, linear equations. And this is kind of a big idea in this part of our algebra. So in our earlier algebra unit, we talked about, we really started with positive and negative numbers, algebraic expressions, talked a lot about what variables are and why we have them, why we use them. We discussed and talked about how we solve one-step equations, two-step equations, through multi-step equations. And so the class that I was working with at the time caught on to that super quickly and did a great job understanding basically how to solve equations. So when we were working through that unit, we were solving for basically a missing number, okay? We used a variable and we learned how to kind of undo the problem in order to solve the algebraic equations. And but what's different between those equations and what we're going to learn about today was those equations had one variable, one missing number that we were looking for. Okay, so our goal was to isolate the variable, and once it was isolated, we could figure out what number that variable represented. When we talk about linear equations, now we have two variables. Okay, so it's no longer solving for a missing number. Now it's those two variables are related to each other somehow, and really an equation shows how they're related. And so when one variable changes, so does the other. All right, so there's not just one solution when we're talking about linear equations. There is a relationship, okay? So I'm gonna show you kind of my definition for what linear equations are. So you might pause your screen and write this down. So a linear equation is an equation that shows the relationship between two variables and when graphed forms a straight line. Now, if you remember, we've talked about this before, but the word linear means line. It's actually got the word line in it. And so linear equations are equations that can be graphed, and when graphed, create a straight line. Okay, so we're gonna look at some examples of, I want to use some word problems to try to make this make sense. Like, what do you mean two variables and how they're related? That doesn't really make a whole lot of sense. But I think if we look at some word problems, that will be a little bit more clear. But let me first start with an explanation, okay? So one thing that I like to bring up when I'm trying to explain what linear equations represent is I bring up my age compared to my brother's age, okay? My age and my brother's age are related to each other. They always have the same relationship because I am 3 years older than my brother. But our ages don't stay the same, they change, right? But as my age changes, so does my brother's. And so really what we have here is a relationship between our ages, and we could show that with an equation, okay? So I'm going to write that relationship down, write that equation down. Okay, so notice the two variables. A lot of times here in these worksheets, we're using X and Y, and it's because um, of the X-axis and the Y-axis. And so it just flows and connects with the coordinate grid a little bit easier, but it doesn't always have to be X and Y. We can choose whatever letters we want. And actually in those word problems I was discussing earlier, you're gonna see they use letters that go with the problem, okay? They have they're a symbol for something else. And so may not use X and Y, they may use L and D or Q and R or something like that, okay? So here's two letters that represent, one of them is my age and the other is my brother's age, okay? And so what I'm gonna tell you is that I'm the older brother. I'm the older brother. So what I want you to think about is just look at this, and I know we haven't really talked anything about it, but want to see, can you reason this out? Which one do you think I am? Do you think I'm the X or do you think I'm the Y? Okay, so think about that for a second. And then a second thought that I would like you to think about is how much older am I than my brother? Okay, so go ahead, maybe pause your screen, think about that for a second. The equation is Y equals X plus 3. So think about which one am I, which one am I, is my brother, and how much older am I than my brother? Okay, so you're back. Hopefully you were able to reason this out. So do you think that I am Y, or my age is Y, or my age is X? I'm older than my brother, so here's the answer. I would be the Y, because my age is always going to be equal to my brother's age plus 3 years. So that answers the second question. How much older am I than my brother? I'm 3 years older. I'm always going to be 3 years older than him, okay? Even as our ages change. And so that kind of brings us to the next thing that we're going to talk about today, which is called an in-out table, a function table. And so I'm going to write that down, and I'm going to write down a definition for you. So just a second. Okay, so we're talking about my brother's age and my age, how they're related, and we can show that as an equation. I'm being the Y, my brother's age is being the X. So the other part of today's video is talking about a function table or a in-out table. It can go by both names, okay? And what that is, and I've wrote the definition if you want to pause it and write this down. A function table or an in and out table is a table that shows different examples of an XY relationship, okay? Now maybe that doesn't have a whole lot of meaning right now, but going back to my example, if I wanted to make an in-out table, basically, kind of make like this T-chart, T-table. X always comes before Y. And really what we're doing when we make one of these tables is we're coming up with different examples, okay? So it goes in one way and then it goes through the formula or through the equation and comes out. And so when X is this, Y is this, okay? So when my brother was 1, put a 1 in for X, 1 plus 3 equals 4. I was 4, right? 3 years older. When my brother was 12, and I'm just making numbers up, right? I'm just picking different points in time. I could have picked anything that I wanted. I could even pick future numbers, okay? We haven't hit yet. But so when my brother was 12, put 12 in for X, 12 plus 3 equals 15. I was 15. My brother's age, my age. Notice X is not always the same number, and as X changes, Y changes as well. And so that's always going to happen in a linear equation because they are related to each other. If one changes, the other will change. Let's pick one more. How about now? My brother is 39. So I'm 42. Okay. So this is an example of an in-out table. Goes in, comes out. But really what it does is it shows examples of this relationship. And this relationship is the linear equation, okay? Y is always going to be equal to whatever x is plus 3. And what you can really do with this is in linear equations, when you write down these different examples, they actually create points on a coordinate grid. And if you do it all correctly, it's going to make a straight line, okay? Well, I guess I'm back. My Wi-Fi is really spotty, and when it goes out, it stops the recording. So I'm going to have to do a little bit of editing here. If it's not exactly perfect, then forgive me. I'm sorry. But it does look like it's back on. So pick it back up where I was, which was each x and y, after it ran through the equation, creates coordinates. An x and a y, 1, 4, 12, 15, 39, 42. These are each coordinates. And if I wanted to, and I had a big enough paper, I may want to choose some smaller numbers, I could plot those on a grid. Okay, 1, 4, 12, 15, 39, 42, okay? And it's going to create a straight line. A linear equation always makes a straight line, okay? So what I want you to ask yourself right now, let's go back to kind of our last video. Looking at the table, I want you to tell me what the slope is from this table, okay? So go ahead and pause it and then come up with that, okay? All right, so let's check out what the slope is in this table. If you remember, when we don't have a graph to look at and we're just using coordinates, we go to the formula sheet and pull up the slope formula, which is y2 minus y1 over x2 minus x1. All right, and we have 3 points here. We only need 2 to find slope. So doesn't matter which 2 you pick. I'm going to pick the top 2 just because they're smaller numbers, okay? So y2, 15 minus y1, 4, or x2, 12 minus x1, 1. 15 minus 4 is 11. 12 minus 1 is 11. So we have positive 11 divided by positive 11, which equals a slope of positive 1. Okay, we could think about that as 1 over 1 even, or 11 over 11. So what that means is it rises 1. Okay, and slope is actually a comparison of 2 numbers. So 1 is the same as 1 over 1. So it rises 1, runs 1, rises 1, runs 1. And so what that means, according to the problem, is as I get a year older, my brother gets a year older. As I get a year older, my brother gets another year older. The only difference is where we started. We're growing at the same age.